Franco Frasconi.
Frasconi. He is a scientist and
Gravitational Physics
for
at
now,
Pisa University.
for 2 decades, he is the man when it comes to gravitational waves. So I was in his lecture, and now just give the.
I try to explain you as better as I can what is the meaning of the gravitational wave detection. So, as I reported on a slide of my presentation, the existence of gravitational waves was predicted by Einstein, the general relativity theory, more than 100 years ago. So recently, a couple of years ago, we detected for the first time on Earth a clear evidence of the existence of these gravitational gravitational signals. Gravitational signals are due to the acceleration of large mass in the universe. When I say large mass, I mean stars and black holes, neutron stars, and so on. And the acceleration of this huge mass produce a deformation of the space-time between our detector on Earth and the source of gravitational waves, which is this huge mass, like a black hole. Okay, moving around in the universe, this black hole produce a deformation of the space-time traveling in the universe at the speed of light. This very thin, very small and very weak signal arrive here on Earth on our experimental apparatus, and now we are able, thanks to the new technology, to detect this small signal, this weak signal.
It's measured by glass, right? Like these inframeters. How do you measure them?
No, we measure by using an interferometer, a Michelson interferometer, having along the two arms two Fabry-Perot cavity. These Fabry-Perot cavity, without entering in some details, are a special technology to improve the length of the two arms up to different hundreds of kilometers, just to have the right sensitivity to detect this small signal, this tiny signal, like a gravitational waves arriving from the space, from the universe, and traveling through the universe. This is the basic idea. The basic idea is that we have the position, we control in very precise way the position of two mirrors along the same arms. When a gravitational wave arrive on our detector, the gravitational wave moves the mirrors in such a way you can measure the deformation of the space-time between two mirrors. And this is the signal due to gravitational waves.
And how does it impact the Earth? Like knowing all this, how does that?
I do not understand your question. What is your
with the knowing and with the knowing this and this thesis, and how does that
change our life?
Our lives. Yeah.
Oh, okay. That's trivial. No, it is not trivial. It's very complex. So far, nobody detected the gravitational waves on Earth. The existence of gravitational waves was and it is based just on the general relativity theory developed by Albert Einstein more than 100 years ago.
So he just put the thesis out there, but he couldn't prove it because he didn't have the technology.
Yes, absolutely. That's the right reason. But now, what can we change? How can we change? How can our life change in the near future, knowing the existence of gravitational waves with zero impact? Our life, I'm pretty sure, at the moment, cannot change thanks to the existence of gravitational waves, for sure. But it is extremely important from a knowledge point of view, because thanks to this fundamental discovery, we can improve our study in the basic physics, and we can develop a new global theory considering gravitational waves as a sort of precursor of gravitational interaction, which is an interaction which is not included in a global theory where we have the so-called standard model. Standard model is another theoretical theory of the physics where all the knowledge we have so far is included for what concerns the high energy physics, particle physics, and so on. As soon as you try to put together the standard model with the general relativity, these two theories altogether do not give the right answer for a global and unique and unification theory. But the reason was that so far nobody was able to detect gravitational waves. Now, since a couple of years ago, more than 2 years ago, we detect gravitational waves for the first time on Earth. We are probably, in the near future, we can develop a global theory including general relativity theory and concerning the gravitational interaction from one side and the standard model altogether. We completely change our view of the universe, and we completely change our knowledge of all our universe. That's the point.
Do you think that there are different physical laws out there in the universe?
I cannot say
Possibly.
anything.
I read something
Why
Hawking's
not?
writing. Yeah.
Why not? Why not? I cannot exclude. For sure, the idea we have now, the knowledge we have now of the universe where we live, is absolutely incomplete. We know just a small fraction of our universe.
Is that why we have the urge to explore, to go
Yes,
out there, right?
yes, absolutely.
Or do you see it as an...
So maybe
there's only 3 reasons why humanity wants to, either they want to explore as an adventurer, as a space tourist, or science research reasons, or simply economics, right?
yeah.
So what is your take on there from a perspective as a scientist?
My perspective is the following. I'm pretty sure that what we know today, it is not a complete vision of our life in the universe, for sure. As I told you, we know just a small fraction on how this universe works. So the discovery of gravitational waves is a good opportunity to revise completely the knowledge and the evolution of the universe. So I cannot exclude that pretty soon, or within 50 years or something like that, we need to rewrite completely some fundamental part of our knowledge on physics.
And what is your thought on humanity becoming spacefaring and becoming multiplanetary? I was impressed by the presentation from Elena, right, from ESA. She says, hey, humanity is already spacefaring, but it's just a percentage. There's always someone out there 360 days. Some Russian, some Japanese is out there, right? But when the point comes and the private sector opens it, it's already happening, and it's just switching, I guess, from the big, remember the huge first computer, the size of a plane, and now it's the size of this phone.
Yes.
Right? So
that's it.
When that happens, and
I'm not able to make any prediction in this direction, but I'm pretty sure that we are not alone in the universe. This is for sure, And pretty
state this. Why would you think that we're not alone?
because for a statistical
Doesn't
problem,
make sense.
that makes sense.
Yeah.
That's it. It's the huge universe. The universe is so huge that I cannot believe that we are alone in the
Explain
universe.
to a 5-year-old child how huge the universe is.
Let's say, don't forget that the signal we detected was 1.3 billion of years light away from our Earth.
My goodness.
Don't forget this point. And this is just the first part of the universe. Okay? The universe, the complete land, if we can imagine a sort of a ruler, we are living in the point of the ruler. The 99% of the ruler, we do not know anything about that. That's a huge number.
So if you would leave a legacy and your footprint here on Earth, what would you like to discover or teach or leave behind? Or what would you be curious about?
Yeah,
what would you not? Yeah.
I cannot teach anything in very precise way. The only message I can send is just be curious. Be
Everyone
curious.
says that.
Be curious.
Yeah.
Because if you are curious, you can get the right information. If you stay there without any perspectives and just waiting.
That gives me shivers. I mean, a man 100 years ago called the most intelligent man on planet, Albert Einstein, he says things so you can come up with anything when you go silent and when you stay curious. And right, and a man like you 100 years later, we have the technology.
Yeah.
It's our life is so short, the 100 years or whatsoever compared to the universe, right?
Let's make a common reflection on this point. Don't forget, if you take a look to the general relativity theory, it's a huge book and it is really very difficult. I can understand people when they say, "Oh, man, I cannot understand that matter because it's very complicated."
This is why it's not been taught at school, right?
But don't forget, this is the final result of a single man in front of white paper with a pencil. Nothing else.
Pencil.
Okay? This means that the human thought is
beyond time and space.
Yes. Is so powerful that can imagine whatever you want without any limitation. The only limitation we have is the technology and our daily life. Nothing else.
Which will evolve and evolve and evolve. Thank you so much. It was a
Welcome.
pleasure.